everybody. Today we are going to discuss the measurement error of spectrophotometry. The error of spectrophotometry is caused by various factors: chemical factors, lack of instrument precision, inaccurate measurement, etc. According to Lambert-Beer's law we introduced before, it is easy to understand that when the absorption thickness is constant, the standard curve should be a line through origin. Namely, the absorbance A is directly proportional to the concentration C, which is subject to Lambert-Beer's law. However, in the actual measurement, different conditions of the end of standard curve appear, as shown in the figure. Sometimes the curve end bends to the concentration axis with a negative deviation, while sometimes to absorbance axis with positive deviation. We call these phenomena the deviation to Lambert-Beer's law. If quantitative determination is carried out in the bending part, a large measurement error will be produced. So, what's the cause of the deviation? First, physical cause. 1. Deviation caused by impurity of monochromatic light. A continuous light source is used in junction with a monochromator. Due to the dispersion restrictions of monochromator and a certain width of exit slit, the monochromatic light separated from light source in a variety of ways is actually a spectral band with certain wavelength range. It is likely to lead deviation of Lambert-Beer's law when taking this as the incident light. The Lambert-Beer's law only applies on the uniform solution with no scattering. If the solution is not uniform with the state of colloid, turbidity, or suspension, the incident light is not only absorbed, but with the loss of reflection and scattering, leading to higher absorbance result and deviation to Lambert-Beer's law. 3. The deviation caused by non-parallel incident light. According to Lambert-Beer's law, it is required to use parallel beam to irradiate vertically. If the incident beam is not parallel, it is not possible for the light beam to vertically pass through the absorption cell completely, rendering the average optical path of the light beam greater than the thickness of absorption cell B. So, the actual absorbance will be bigger than the theoretical value, leading to positive error. The above three are physical factors. Next, let's take a look at some chemical factors that can lead to deviation to Lambert-Beer's law. 1. Deviation caused by too high concentration. The absorption coefficient kappa is related to the refractive index N of the solution. When the concentration of the solution is 0.01 mol per liter or lower, N is basically a constant, which means that Lambert-Beer's law applies only to solution of low concentrations. The absorbance result deviates from Lambert-Beer's law when solution concentration is too high. So please think about how to avoid the deviation to Lambert-Beer's law when concentration is too high. 2. Deviation caused by chemical reactions. Dissociation, complexation, tautomerization, and chemical changes of solute can also cause deviation, and the dissociation of color compounds is a major chemical factor. For example, the chromogenic agent potassium thiocyanate and ferric form a red compound of thiocyanate iron, which has a falling equilibrium equation. This gives rise to the reduced concentration of thiocyanate iron, so the absorbance decreases and deviates from Lambert-Beer's law. Second, measurement error of photometric method. Measurement error refers to the error introduced when measuring absorbance or transmittance using spectrometric instrument. The absorbance and transmittance intensity are in relationship of negative logarithm. So the scale of absorbance is not uniform. In general, when the transmittance is 15% to 70%, absorbance is 0.15 to 0.8. The relative error of measurement is not so huge. This is the appropriate absorbance range in spectrophotometric analysis. The purpose of photometric analysis is to obtain the solution concentration C by measuring the transmittance T. The relative error of target concentration generated by reading error dt is expressed as dc divided by c. According to Lambert-Beer's law, A equals minus 0.434 ln t equals kbc. By differentiating both sides of which the relative error of the concentration measurement error is expressed as error equals 0.434 dt divided by t ln t multiplies 100%. Suppose the relative error of the transmittance for a certain instrument is dt equals 0.005. Then respectively calculate the absolute value of relative error of responding concentration C with different t values and plot the curve of the absolute value of relative error versus t. We can see from the curve that when A equals 0.434, the relative error of measurement gets the lowest point. The relative error of the photometric measurement is acceptable when transmittance is 15% to 70%, with the absorbance of 0.15 to 0.8. 3. Instrumental error. Factors leading to the instrument error include cuvette quality, the sensitivity of galvanometer, unstable light source, the performance of the prism, installation conditions, and the quality of photocell, etc., all of which can cause the analysis error. 4. Operation error. It is generated due to the difference between the experimental conditions and the correct conditions of the analysis, such as the condition of chromogenic reaction and the measurement condition. The above 4 factors are the main sources of the error of absorption spectrophotometry. They are 1. The deviation from Lambert-Beer's law. 2. Measurement error of photometric method. 3. Instrumental error. 4. Operation error. In the end, there are 2 questions for you. 1. In order to improve the accuracy of measurement results, from what aspects should we select or control the conditions for photometric measurements? Second, nickel content of a certain steel sample is about 0.12% and is detected by spectrophotometry using dimethylglyoxime. After dissolving, the steel sample is transferred into 100 ml volumetric flask to have the chromogenic reaction. The absorbance is detected in a 1 cm cuvette at 470 nanometer. If the measurement error is smallest at this point, then how much sample should be taken? That's all for today.